Hey Shane, today I've got a weird little project and it has to do with this credenza or buffet or whatever the hell it is. So, quick story time. During COVID, during the pandemic, my wife and I lived in San Francisco. And during the pandemic, like a lot of people, we didn't need to be there anymore. So we decided to move down to San Diego for a temporary stay. Well, it's been 2 years. That temporary stay is now a permanent stay. And so it was finally time to get our stuff that we put in storage shipped down here to San Diego. Well, at home we've kind of moved on. We've gotten all new furniture and we don't need this stuff anymore. So that means that it gets to live in our office. So yesterday we had a bunch of stuff shipped here, including a couch and stuff like this, and this beautiful buffet credenza. But not all went well during shipping. As you can see here, I'll show you in a second, we had some damage and we had a broken drawer pull. So I want to make something cool out of this opportunity, and that's today's project. Okay, so instead of doing any normal drawer pull for this, I thought, well, let's take it to the next level. Let's do it Blackland style. And so what I want to do is take this. This is a PVD-coated stainless steel Blackbird, and it's really sweet. So here's my idea, and here's what we're going to do. We're going to take this, we're going to chop it right there-ish, and we're going to thread up that way. So we're going to turn this into a drawer pull, just like that. Way over the top, really kind of stupid, not the best use of my time, but it's going to be really cool when it's done. So, what you guys don't realize is that we now have a machinist next door. His name's Tyler at Kinetic CNC. So I'm going to walk this over there to him right now. I'm going to show him my project. I'm going to introduce you to Tyler. And we're going to make the world's coolest drawer pull. And we're also going to make the world's least valuable Blackbird, all in the same time. Follow along. See you soon. All right, so we're going to commute over to Tyler's. Check out the new 944 I just got. So, Tyler is a friend of mine, and I finally convinced him. Hi, Mateo. Nice. So I finally convinced Tyler to start a machine shop here, and I worked really hard to get him in. So we have a long commute to Tyler's. He's now right here. So he just moved in this week. And let's go see what he says about this. Hi, Tyler.
Hey, what's up?
All right, so introduce yourself. Tyler is owner of Kinetic CNC.
That's right.
And he's my friend, and he just moved in. So what else you got? He's an engineer as well?
Yeah, seven or 8 years as a engineer, 7 years at General Atomics, and then a year at a small laser company. Just doing hardware engineering, mechanical engineering, pretty much kind of whatever they threw at me, really.
Yeah, Tyler's also a super nerd, really technical, makes weird potato cannons and stuff like that. Robots.
Whatever I get my hands on, yeah.
Yeah, so Tyler, like I talked to you earlier, I want to make this into a drawer pull for my credenza, which is a word that Tyler just learned yesterday.
Yeah, never heard of that.
So
you're calling me the nerd.
yeah, so what I want to do, I want to chop the handle kind of in half and then thread it. We'll like figure out a way to mount the headpieces together, like epoxy or something simple. It doesn't need to be that complicated. And then, that's it. So it should be pretty straightforward. I just need to run a screw through the back of it.
Yeah, do you know what type of screw you want? Like 832, metric?
I don't really care.
Okay. How about we just use whatever tap I have on hand? That's my favorite tap.
That works for me.
All right.
We'll just make it meet whatever screw you tap. That's an easy solve.
Yeah, that's fine.
So how can we do it? By the way, here's Tyler's shop. Just getting set up.
Yeah.
Small so far, but we got the 3-axis Fidal that Tyler has super modified. And that's what we run in a lot of our parts.
Yeah, we got that. Brand new sandblasting cabinet I just finished yesterday with a whole lot of mods. And then my very first machine that I ever owned right here.
Yeah, tell us about this a little bit.
Yeah, this is started in my garage maybe 8-9 years ago, and kind of just got me in love with machining and manufacturing and design. So once I started tinkering with this, I just pretty much knew what I wanted to do. And yeah, this thing was a workhorse. It made a lot of really cool parts, a lot of fun parts. I made this little 4th axis gizmo so that this is just obviously just all CNC controlled, but I can go manual right now. And then with the fourth axis, it's just adds that additional rotational axis along the Y or the X axis. It allows me to hit really complex angles, and usually I just run Teflon parts in this just because it doesn't have all that much horsepower. So it's a fun little guy. I make a lot of cool parts with it.
Yeah, see, Tyler's a nerd. So how are you gonna make this drawer pull for us? This is super important.
Yeah. So the problem is if you kind of look at it, there's this ridge here, and that ridge makes it really hard to grip without having to choke all the way up on the handle. So like if I just stuck this in here and tried to grip it, it would have room to kind of wobble. So what I'm thinking is if we take some aluminum bar, chuck it up in there, bore a hole through it that's the same diameter as this middle section here.
Yeah.
Then we can take that little round out that we just made, chop it in half or something like that, and then kind of encompass it a little bit, and then put that in, so that way this thing's clamping on the aluminum, which is then clamping onto the part. And I think that should give us like relatively good like center line concentricity in the lathe, and give us pretty good rigidity when we just do the chop operation and when we drill and tap.
Okay.
But I'm just kind of throwing an idea out there. It's the only way I can think of holding it right now. And that way the aluminum doesn't mar this nice material. It doesn't hurt the PVD coating or anything like that. So.
Right. Okay.
So yeah, let's get some chips flying with some aluminum, yeah? Just need my trusty old brush. Where are you? This is the first time I've operated the lathe since I moved in. Just got it leveled up, ready to go. So.
Tell us a little bit about Sheldon here.
Yeah, so I knew I wanted a lathe because I knew absolutely nothing about doing lathe work. And I found a guy who just did a really great restoration on this lathe. It's from like the 1940s. And he did a great job restoring it, and it functions great. It's not crazy powerful. It's not crazy accurate, but it helps me make a lot of really cool, unique little fixtures.
Right.
And I don't use it really for any precision work. I don't use it for any job work. I don't use it to make any money, but I've made a lot of really cool stuff that helps that machine, helps stuff around the shop, stuff like that. So I actually don't have any air on this, so we're just gonna go all oil.
What's the difference between oil and air, and why do you need either?
I like to have like a misting system. So like there's this little oil mister. It uses a Venturi in it, and air comes in, and then it pulls from a coolant supply. Just to like help air and mist, put some mist and air right on the cut. It just helps evacuate chips and keep the part and the bit cool. But since I don't have that right now, I'm just going to use like my little trusty oil dabber guy. Okay, so I'm just going to take a quick skim cut on the outside, face it, drill a hole through it, and try to get that hole to be just slightly under the diameter of the razor. So. All right, so just got it a little cleaned up. Not too crazy of a surface finish, but it's okay for now. Now we're just gonna.
Check it out.
Yeah, sure.
So what's the point of doing that?
I just wanted some nice material. I'd rather not have this showing, and I needed a little bit more meat than what we originally started with. So I'll probably be parting it, right about where it meets the original stock material.
Right, so that's just the prep to give you a clean surface?
Yeah, I'd rather just have a nice, clean, uniform surface that's flat and perpendicular to the face here and relative to the spindle. So we're gonna give this guy a little spot drill here. Bring this guy up in here. Tighten that guy down. Press it. Good. All right. And then now we're going to grab a drill. It's the right size. So we got a 1/4 inch. So the razor, I believe, is 0.425 inches in diameter.
You work with inches?
I work with.
I thought you were an engineer, Tyler.
You know what? It's hard to escape the inch world when you get into the machining world. Kind of depends on what kind of work you're getting. If everything's in inches or everything's in millimeters.
This is a constant source of struggle with our other manufacturers.
Oh, I can imagine.
Because they love the inch, and
Yeah.
I hate it. Everything's in millimeters.
Yeah, it's just kind of how it is.
Yeah.
I have no problem with converting inches to millimeters. I mean, and millimeters to inches. It's just I've gotten so used to it now that the units of measurement are just totally arbitrary. And I'm working with this is an inch machine. All the feed rates stated here are all in inches. My Fidal, I can convert it to a metric mode on the Fidal, but it kind of complicates things, especially since the ball screws in it are all in inches, and it's just kind of a hassle, to be honest.
Yeah.
But when I was in school doing physics, that's all we did was metric, and I loved it. It's so easy.
Hey, so what's the benefit of a manual lathe like this?
Just quick setup. If I wanted to program this part, I'd have to, go and program the part to do this entire setup. It's weird.
Right, so you'd have to write code for this.
Yeah, write code. Then you got to set up the machine. Then you got to assign tooling, and it's just kind of it's a longer process. I mean, it would still be very quick for the part that we're making. It'd still be super quick on a CNC, but. CNC is just better for production runs and whatnot.
Right.
Doing lots of them or doing more complex parts and whatnot.
Yeah. But for something like this, just a one-off,
Yeah.
the manual lathe is quicker and easier.
I think so. So we're just going to do a nice deep drill on this guy. And luckily this drill is just under the, I'm gonna bump the speed down just a little bit. Right back in.
How do you know what speed to turn that pulley with?
It's all by feel on the manual lathes, at least for aluminum and for this particular setup. It's just, I could feel if I start cranking on it right now, I'm gonna either stall the motor out or break the bit. So I just kind of go by feel and I look at the chips, and the chips are still evacuating that hole. And if they stop evacuating, I'll feel it. I'll physically feel it bind up, and I'll pull back and re-lubricate and clear the chips. And then in terms of the feed rate for actually feeding with, like, say the insert tooling, that's kind of just by using this chart here. I can automatically set this to make passes at a certain feed rate. It's not NC by any means, but you know, it'll automatically feed the machine, and you can get some really cool finishes where it's all hands off.
Huh.
So
that's cool. So then, does manual lathe and manual machining give you like better feel, so that when you switch over to CNC, do you like have better knowledge about it? Like, should people start on manuals?
That's a good question. You're certainly going to learn a lot on a manual lathe, or on a manual mill or lathe. I didn't start on one, so I can't speak to that. But I will say, just getting in there and starting to machine is going to be huge. A manual mill is going to teach you all about fixturing, about what holds a part correctly. That's really important, and also like what size tooling to use, how fast to feed, spindle RPMs, and just learning feed rates and whatnot, coolant, and definitely learning like tolerances and how easily just the smallest amount of movement can mess up tolerances. So, but I would say if you can get a manual machine or a manual lathe for really cheap, like I got this lathe. I mean, I got this lathe for like, I think it was like $2,000. So that was a really cheap investment to start off, especially for the size of this thing.
Yeah.
And then same with my little CNC mill. That thing probably goes for maybe $3-4 grand used, and you can get that thing all ready to go. Just plug it into a computer, and it's gonna start milling. So I think that since the future is obviously NC and CNC, I think that would be a better place to start.
Yeah.
There's so many resources online that it's, especially if you just start with like aluminum and plastic, it's gonna be pretty hard to mess it up. So.
Got it. All right, what next?
I am going to deburr the part just a little bit. Just get this edge cleaned up. I still want to get a tool for that. That mounts onto the lathe, makes a nice chamfer, but just don't have one yet. That's all right. Let's see. I noticed there was this issue on the face, some kind of mark that we didn't hit at the beginning, so I'm just going to clean that up.
Do we care?
Yeah. Why do we care? I already checked. All right, let's go. Let's part this. We're going to part it now.
What is parting?
We're going to remove.
Uninitiated.
We're going to remove that piece we just made from the bar stock.
So you're cutting it off from the rest of it.
Yes.
Yeah.
So I need to make sure my blade will reach the center, because all it needs to do is breach that center point, and it'll come off. So it will.
Right, so you just need it to reach into the hole, obviously, because then as you spin it around, it'll cut through.
Yeah, exactly.
Instead of going all the way.
Yeah, and for this, I'm just going to reduce the speed of the machine by quite a bit, because this is a pretty arduous task for. This is the scariest task in a lot of lathes, is parting, and
Wow.
there's a lot of force involved. There's a lot of torque on the tiny, slim little tool. I've had these shatter before, and it's not fun when they do.
Aluminum?
No, I was doing some tool steel on this.
Shattered?
Oh yeah, it exploded more like.
What?
Yeah, so
Let's go.
I'm gonna set this up, and then I just like to keep my guy here, constantly lubricating the part, and I'll just feed in. Lovely sound, right?
Yeah, I love that.
So while we're here, I'm going to back it out. And this is a time I like to take the opportunity to quickly burr this inside edge.
Why do it now?
Because when it's out of the machine,
You can't.
it's kind of hard to get a really nice clean edge on that.
Got
I mean,
it.
I can.
So it's
this
not
part
you
is
use the
just-
lathe to deburr it,
Yeah.
rather than having to like awkwardly hold it by itself.
Yeah, and
Yeah.
I mean, it's not like this part's going anywhere. It's just going to be used for a fixturing, but still, it's just a practice that I've always done.
Tyler, so now that you have the parts in hand, show us how it works, because I don't really understand the plan. I know you've got a good plan, but our watchers definitely want to know what the plan
Sure.
is. So,
Yeah, what I'm trying to do is I'm just going to be cutting this guy directly in half,
okay.
and that'll leave this opening here on both sides of these two aluminum pucks that are going to sandwich this inner diameter of this razor handle.
Got it.
So that the jaws of the chuck itself are actually going to be providing that squeeze around this.
Okay.
And
so you're
hopefully-
making a collar for it. And
Exactly, that's a better word for it, a collar, yeah.
Okay.
So once I chop this guy right in half, we'll be good to go.
Got
How
it.
I'm gonna do that, I haven't thought of yet. But that thing is out of commission right now. I'm still cleaning and refurbishing that cold saw. So I'm probably gonna break out
this
my
beauty?
hands. Huh?
This beauty?
Stop, don't give that camera time. Don't do that. Yeah, this is just a really old bandsaw, probably from the 80s or 90s, and we got it for a pretty good deal. I found it on Craigslist, and it has a pretty cool like automatic feed system. So you can just let the hydraulic system do the feeding for you. I think most bandsaws have that anyway. I mean, it's pretty old technology, but essentially there's just this.
But tell us how the whole thing works. Like, what's it for, and why is it so damn big?
Yeah, I mean, you can take a look here, and you can see why. Look at all this metal and aluminum that I have to cut, these huge chunks. I mean, this thing's the size of my freaking head almost. And these huge slabs everywhere, giant round stock. So you want something that's big enough to cut it. That little cold saw over there, even if it was working, wouldn't be able to cut a lot of this material.
Right.
Sure wouldn't be fun either, because you just
So-
sit there and hold it.
So bandsaw here, blade is held in place by these, which are adjustable, right?
Yeah,
So
you can
fit the
adjust
part
this.
in?
Yeah, so that way you get a more straight cut based on the size of the part.
Because you want it to be
size this.
no bigger than the part, basically, right? You want it to be as rigid as possible.
Exactly. It's gonna have this plate a little bit, but it's okay. Just scrap plate.
All right. So Tyler, we got the puck cut
Yes.
for your little collar.
Yep.
Show us how it's going to work now with the two pieces.
Yeah. So you can see how I got that perfectly down the center, right?
Yeah.
No, not quite.
Wait.
But it doesn't matter.
It doesn't matter, right?
So it's gonna sit in this like that.
Uh-huh.
This guy's gonna come in on top,
Yeah.
and you can see that there's that gap now because
Right.
I made the diameter just a little bit smaller, and the thickness of the blade cut also helped us out. So now we're just gonna squeeze this guy in the chuck, and that means the rigidity of this part is centered around this puck instead of it being centered around this small little diameter here. So we're gonna see if this will work out. The only thing I'm a little bit concerned about is the groover, or the parting blade on the stainless steel. The reason why is you have all these ridges. So as it's going in, it's gonna be like tick, 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 hitting those ridges every single pass, and could work. It might work. It might not work. If the blade blows up, it's fine. I can always just regrind a new tip. So we'll just give it a shot.
Just the tip?
Just the tip, dude. You
Okay.
already know. Oh, I need that in there. Where do I move this guy now? So this works.
Yeah,
I
my
hope,
fingers
I hope the
crossed.
3 prongs don't have a...
Look, honestly, even if it blows up, that's good YouTube content too.
Yeah. Okay. So I'm going to turn it on and we'll see how much wobble we have in the part and maybe have to readjust. But hopefully it looks good. So see that wobble? Do you kind of see that?
Yeah.
So I'm going to try an old machinist trick where you just kind of tap at it with a hammer. And since this part is going to get removed anyway, we don't really care if it gets slightly damaged, but I'm just going to use a mallet. And we're just going to tap on that part until we see it running true and straight. Oh, my mallet's working. Who would've thought? Let's get running faster. That's scary.
Yeah.
It's already looking a lot better. Hard to tell.
I agree. Hard to tell.
Yep.
Now, are we actually bending the steel, or are we bending the aluminum?
No, it's just kind of like shifting everything in place till everything falls kind of on center.
Do we have to retighten the chuck?
No, nothing has to be retightened. It's in there. Cool. But I think it's good enough for now, especially considering what we're doing here, which is not aerospace parts. So.
Are you denigrating our drawer pull?
Yes. Sorry, bro.
Okay. It's pretty messed up.
Slow and easy wins the race. All right, I think we're through the grooves for the most part. Yeah, we're through the grooves, so I can actually start feeding it a little bit more now.
All right. Tell us how a tap works while you hold it there.
Yeah, essentially it's a cutting tool that has a certain thread pitch that have little tiny teeth along that thread pitch, and there's lots of different types of them. This one right here is a bottoming one, and as you're going into the hole, it will actually drive itself into the hole with every turn, almost like how a screw works.
Right.
And every turn, it's removing material away from these flute valleys and from the cutting edges to form threads that you can just screw anything into.
Got it. Okay, so this will let us put our screw into it so I can mount my drawer pull.
Exactly.
All right.
Yeah. And there you go. So what I'm going to do here is I'm going to actually set this up to, since we're tapping some relatively hard material, you really shouldn't ever do a tap freehand. It's really important to always make sure that you're dead nut straight, always. So being straight onto the hole is super important. So that's why I have this tool here, which is going to help us out a lot. Well, I'll show you the tool really quick. It's a so precision ground 1/2-inch shank with a spring-loaded plunger. And we're just going to take our tap here. I just put some oil on it. And we're just going to put it kind of right on that hole so it kind of seats in there real nice. And we'll bring this guy forward. And then we're just going to clamp, we're going to bring this guy in. There's a little countersunk hole right here.
Oh, okay.
And it just kind of seats in there. I'm just spring loading it now. So now this guy is really just dead nut straight with that hole. So now I can just go by hand and then start tapping. And stainless steel, it doesn't tap super easily, so I have to
You do it all by hand?
Yeah, I'm gonna do this whole thing by hand. In the CNC machine, I'll have it rigid tap usually, but it's kind of sketchy on the lathe. And it's not tapping very easily. I mean, it's really hard material. So I'm kind of just going back and forth, creating some chips, and then breaking the chip, and then creating some chips, and then breaking the chip. Just easing my way in there.
All right, Tyler, so we just pulled the thing off the machine, it tapped.
Yep, tapped, and it looks relatively centered for a drawer pull, so I mean, look at
Looks
that.
good.
Yeah, and then the finish on this doesn't seem to have been marred at all. Maybe just some slight scuffing just along this ridge, but I don't think it's that bad. Especially
Out of
if,
focus.
oh.
All right, let's get a look at that thing.
Nice, look
Dude,
at that.
that's so
drawer pull.
freaking cool.
That'll be a really cool drawer pull for sure. It's like 0.2 inches. It goes in 0.2 inches depth.
All right,
How thick is the drawer?
we'll find out.
Let's go.
Okay, you working with?
Yeah.
All right. Here's Tyler's sweet ride, by the way.
Zooty.
It's a nice, cool day here in Santee.
Yeah.
Just a breezy 102 today. Hey, Teo. Teo's jamming out in here.
Where's that?
Keep going. All right.
I think it's perfect. I think it's gonna be perfect.
It's gonna be perfect, dude.
Come on. We can always throw a washer in there. Oh yeah. Look at that. First try, dude. That is so cool.
So stupid.
Oh my gosh.
Oh man, Tyler, I love it,
That's sweet.
dude.
You picked a good color for it and everything too.
That's
PVD
so
coating, that's so
funny.
cool.
All right, I'll get some better B-roll of this later. But dude, fuck yeah, Tyler, good job, man.
Sweet, dude.
All right, Tyler,
Oh, yeah.
thanks for quick work. That was like an hour.
Yeah.
If that.
Hour. Yeah.
Sweet, man.
Yeah, man. No worries.
That extra half the handle is your payment.
Wow. That's so generous.
All right, dude, we'll see you around.
All right, man.
Thanks.
See you later.
All right, so we're finally done with that project. It took like an hour or something. Pretty fun, and I know you guys are gonna really like Tyler. I'll probably put he doesn't have a YouTube channel yet, but he's gonna have one, so I'll put the link to that in the description as a placeholder. Go follow him. He'll be making a lot of our stuff going forward. Super cool guy, obviously really knowledgeable. But guys, look at this thing. This is, I don't know, this might be my favorite project we've done. It's pretty stupid. I don't know if it was a good use of our time, but look at this thing. Oh man, it makes me super happy. So I'm glad the credenza is fixed. I'm glad we got Tyler introduced to you. Maybe we'll replace these ones with a saber head, who knows? I don't know. Anyway, thanks guys, follow us. We're gonna do more content like this, these weird videos, weird projects that I have in mind. I have a lot of ideas for this stuff, and we'll intermix those with the more serious production stuff and the more razor focused things. But let us know what you think. Let us know if you like this type of content, and of course, like this video, subscribe, all that stuff. We'll see you next time. Thanks.